This tutorial will illustrate one technique for designing foundations with overturning using SAFE. In this approach, we run the analysis twice. First, with allowable factors to verify the soil bearing pressures, and second, with strength design factors for designing the foundation. Our foundation is a simple mat or raft with 3 grid lines in each direction supported by soil springs. It is loaded with dead, live, and earthquake load patterns. In addition to the self-weight of the foundation, the dead load consists of column loads of 40 kips each. The live load is 60 kips at each column, and the earthquake load is modeled as 10 kips up along the A grid line and 10 kips down in the C grid line, thus creating an overturning moment. For this analysis, we are ignoring the lateral load on the foundation. We have previously set up the load cases for checking allowable soil stresses. In addition to the elastic cases of dead, live, and earthquake, we have a number of nonlinear cases that combine the dead, live, and earthquake patterns. If we select the dead plus 0.7 live minus 0.525 earthquake case, we can see how the patterns have been applied using an analysis type of nonlinear allow uplift. Next, we will run the analysis so that we may display the soil bearing pressures. Looking at the maximum values, we see that all of the bearing pressures are negative. This means that there is no net uplift on the foundation. Next, we would typically verify that the bearing pressures do not exceed allowables. Assuming that this is the case with our model, we will move on to the design of the foundation. For the foundation design, we will start with the same model, but without all of the nonlinear load cases. We will use nonlinear load cases, but will generate these from load combinations created by the program. Before we ask the program to generate the load combinations, we will go to the Design Preferences command and verify that the selected code is ACI 318. Now we will go to the Load Combinations command. Here is where we will ask the program to generate the required design combinations. Click the Add Default Design Combos button, and then unclick all the boxes except for the Strength or Ultimate option. A quick review of the design combos shows all the factors used. Including plus and minus earthquake combinations. Again, these combos were generated for the ACI 318 code. However, the design combinations generated by the program use linear elastic load cases. Because we want to remove the soil springs if there is any uplift, we want the analyses to be done using nonlinear load cases. SAFE offers a quick and powerful way to convert our design load combinations into nonlinear uplift load cases. We will convert all of the design combinations into nonlinear cases. Reviewing the load cases, we see that the loads are now combined within the nonlinear load cases using the same factors as previously used in the design combinations. Returning to the load combinations, we see that our combinations have been revised to simply take the corresponding nonlinear load cases and apply a factor of 1. We can now run the analysis and design. This concludes this tutorial on Foundation Uplift modeling.